Hello, welcome to the estimation class. So today we'll see the problems on the lathe. Estimate out the time for threading on a 3 centimeter diameter aluminum bar of length of 10 centimeter by a single point tool if 3 threads per centimeter are to be cut and speed of per is 80 rpm. Assume suitable approach, overrun, and number of cuts. Here you can have the diameter of the rod is 3 centimeter, that is 30 mm, and n is the 80 rpm. The length of the thread is 10 centimeter, or that is nothing but a 100 mm. That is. Then pitch is given, that is pitch equals to 1 divided by number of threads per centimeter, that is 1 by 3. That is given that 3 threads per centimeter. Then 0.33 centimeter or 3.3 mm. Approach plus over travel length, that will be taken as 7 mm. The number of cuts for the aluminum will be taken as 4, that is. Then time required for threading per cut is equals to L plus 7, L plus L plus 7, L plus 7 divided by pitch into N, that is L will be taken as 100 mm plus 7 mm divided by 3.3 mm is the pitch and 80 rpm is the speed, that is 0.405 minutes per cut. Then total time required to complete the threads, the number of cuts will be required equals to 4. So the time required per cut into number of cuts, that is 0.405 into 4 equals to 1.62 minute, that is. Then determine the next problem. Determine the time required for cutting the 2 threads per centimeter on aluminum bar stock of 3.5 centimeter diameter and for a length of 10 centimeter. Assume cutting speed as 11 meters per minute and neglecting the approach and overtake of the tool. Here the pitch is 1 divided by 2, that is 0.5 centimeter, or you can say that is 5 mm is the pitch. Diameter is given 3.5 centimeter, that is 35 mm. Length will be 100 mm and S equals to 11 meters per minute. Neglecting the approach and overtake, the time required per cut is equals to L divided by pitch into 100 into S divided by pi d. That is S equals to the speed, that is 11 meters per minute, then divided by pi into 30 equals to 35, that is 0.2 minutes. To cut the full depth of threads, number of cut will be required 4, that is. So therefore the 4 number of threads 2.2 into 4 equals to 0.8 minutes, that is. Next you can have the estimation of the time required for tapping. There is a 2 centimeter diameter the hole and with a 3 mm pitch the tap in MS blade up to the depth of 3 centimeter. Assume the cutting speed as 10 meters per minute and the return speed of the tap as 2 times the cutting speed. Here the diameter, that is D is equals to 2 centimeter, pitch is 3 mm, L equals to 3 centimeter, or that is 30 mm, speed equals to 10 meters per minute and return speed is 2 times the cutting speed, that is 2 into cutting speed. So here you have to require the tapping, that is the time required for the forward stroke plus time required for the return stroke, and that is gives the total time required for tapping per cut, that is to complete the threads number of cuts will be required, and that you have to multiply it and you have to calculate the total time required for the tapping. So here the time required for forward stroke, that is L plus D by 2 divided by pitch into RPM. D is the diameter of the tap and RPM equals to 1000 into S divided by pi d, that is. So that will be 0.34 minute. then time required for the return stroke is half the time required for the forward stroke. So that is half into 0.084, that is 0.042 minutes. Then total time required for tapping per cut is equals to 0.084 plus 0.042, it is 0.126 minutes per cut. That is number of cut required to complete the threads, that is equals to 6. So the total time required for the tapping is time required per cut into number of cuts, that is, so that 0.126 into 6, that is 0.756 minutes, or you can say that is 45.4 seconds. Next, you can calculate the problem, that is same problem, that is the tapping. Estimate out the time required for tapping a 2.1 centimeter diameter hole with a 2.5 mm pitch the tap in a mild steel plate up to the depth of 3.5 centimeter. Assume cutting speed as 11 meters per minute and also assume the return speed of the tap is twice the cutting speed. Number of cuts required is 6. Here diameter is 2.1 centimeter or the 21 mm, pitch is the 2.5 mm, depth is 3.5 centimeter, and S equals to 11 meters per minute. Return speed is 2 times the cutting speed. Number of cuts equals to 6, that is. As you know, that is the time required for the tapping is 3 by 2 into bracket L plus D by 2, pitch into 1000 S divided by pi D, that is. Here the 3 by 2 is adding, that is the total time required for the forward and the return stroke. That's why I have taken that is a 3 by 2. L plus 21 by 2 divided by 2.5 into 1000 S, that is 11 divided by pi d, pi into 21, that is 0.163 minutes per cut. Then total time required for the cut to have the full depth of threads, that is 6 cuts will be required, that is 6 into 0.0163, that is 0.978 minutes. That is next. Now we can have, that is very important, the problem in your the lathe machine, that is estimate the machining time required, to complete the job as shown in figure. The basic raw material of 50 mm and 100 mm length, cutting speed for turning 300 meters per minute,